Welcome to day 2 of Unit 11. More identities. So yesterday was just the trig identities that were reciprocals and tangent and cotangent. So you knew most of those. Today we're going to add to that. So we're not throwing away yesterday's. We're still going to need those. Today we're going to talk about what are called the Pythagorean identities. Sounds fancy. It's not as fancy as it sounds. So let's think back to the unit circle. Wasn't that long ago. Alright, there's our unit circle. We knew the radius was 1. That's what made it the unit circle, because the radius is 1. So it was the radius equals 1 unit circle. And remember that this was x and this was y. And based on the little triangle there, and the fact that I just called this the Pythagorean identity, x squared plus y squared equals 1, because that's the Pythagorean theorem. A squared plus b squared equals c squared. But for the unit circle, we might remember that x comma y was also cosine comma sine. So this means that x is cosine squared of whatever the angle is plus sine squared of whatever the angle is equals 1. That's a trig identity. So regardless of the angle, whether it's really small right there in the first quadrant or whether it's way over here in the third quadrant, whatever that angle is, cosine squared plus sine squared equals 1. Now, most people don't say it that way, even though that is what flows from x squared plus y squared equals 1. Most people say it this way: sine squared plus cosine squared equals 1. Obviously that's the same thing, but that's how most people say it and remember it. So I'm going to write that one down and box that one up. And that's the only one you have to remember and memorize, and it's the one that we use not frequently in calculus, but it comes up in calculus. So you need to remember that one. There are 2 others, but the other 2 come from this one. So if I'll divide everybody by sine squared, watch what happens. We'll get another one. So sine squared plus cosine squared equals 1. But then I want to divide everybody by sine squared. So that gets me 1 plus, let's see, cosine over sine is cotangent, and they're squared, so cotangent squared. And 1 over sine, the reciprocal partner with sine was cosecant. So there's a second Pythagorean identity. But it's really not as important as the first, because if you can memorize the first, you know how to get to the second. Divide by sine squared to get to a second one. You might guess to get to the last one, we'll divide everybody by cosine squared and see what happens. So sine squared plus cosine squared equals 1. Let's go through and divide everybody by cosine squared. Right, perfectly legitimate algebra step there. Just divide everybody by cosine squared. Sine over cosine is tangent. So tangent squared. Cosine over cosine is 1. And 1 over cosine is secant. So secant squared. So there's our third Pythagorean identity that we get when we divide by cosine squared. So those are the 3 new ones that we'll use today. You could rearrange these and use them differently. So like if we're looking at this one, if you wanted to know what tangent squared is equal to, well, you just move the 1 over. That'd be secant squared minus 1. But that's not a separate identity. That's just related to the first one. So sometimes we use them in a little bit different order, but you don't have to write down a new one. We can know that if you move 1 over, you get this version of the identity. So it's the same identity, it's just a different way it looks. All right, let's work some problems with these. Yesterday they were all verify, which meant they basically gave you the answer. Today we're not going to give you the answer, they're just going to be simplify. So we're going to work on, rather than having to pick a side, there's only going to be one expression, and we'll work on that and simplify it and hopefully get something that's simpler than what we started with. So let's simplify secant of theta times cosine of theta. Well, there's nothing squared. Squared is the giveaway that something Pythagorean is going on. There's nothing squared here, so I don't think this is going to be Pythagorean. This looks more like a yesterday problem. Secant is 1 over cosine. Cosine I could just leave as cosine. The cosines cancel and I'm just left with 1. And so that simplified to 1. So that didn't even use the Pythagorean identities, but it's in there to emphasize that the ones we learned yesterday we still need to use. We still need to know those. Number 2, simplify secant squared theta minus tangent squared theta all over cosine squared theta. Okay, well there's squareds all over the place on that one, so I am definitely alerted. My brain is sending out alarm bells that Pythagorean is going on here. So I'm especially thinking the secant and tangent are related to each other. In fact, secant squared minus tangent squared. So if I use this and I rearrange things, if I move the tangent squared over, secant squared minus tangent squared is 1. Some people see that and use that, and that is completely okay. Other people take a little bit longer approach. They see secant squared and they say, well, I can replace secant squared with tangent squared theta minus 1. Or excuse me, tangent squared theta plus 1. So I'm going to go the long way around and show you that it gets you to the same spot. Minus tangent squared theta. Tangent squared minus tangent squared cancels out, and you're just left with 1. I'm okay if you can start here and get all the way to here, because you're just rearranging this identity. So if you're comfortable with that, I'm comfortable with that, and it's probably the preferred way to go. Sometimes things get complicated and you don't see it right away, and you end up doing this, and then things cancel out, and it's fine. It's no big deal. You just maybe realize you could have done it a step quicker. Alright, cosine squared. Well, I could rewrite that as 1 minus sine squared, but that would be making things more complicated rather than simpler. 1 over cosine, so the reciprocal partner with cosine is secant. So secant squared of theta. Number 3, cosecant of, I'll use x this time just to mix it up, minus cotangent of x times cosecant of x plus cotangent of x. Let's see what happens when we simplify that. I could replace with sines and cosines right now, but that would make a bit of a mess. So I think what I want to do is FOIL this and see what happens. So first would be cosecant times cosecant. That's cosecant squared of x. Outside, inside. If I'm paying attention, these are going to cancel each other out. Cosecant, cotangent, positive. Cosecant, cotangent, negative. They cancel each other out. Those are, name blank. When you change the sign in the middle and you multiply them, the outside and inside go away. It'll come to me later what that's called. We've used it before. Anyway, inside, outside cancels. The last will be minus cotangent squared. Okay, now that looks like Pythagorean. So I look back at the top, and I've got 1 plus cotangent squared equals cosecant squared. So if I rearrange that to look like cosecant minus cotangent squared, that would be 1. It's kind of the same deal that happened up here. If you recognize it as 1, great. If you just want to say that cosecant squared is 1 plus cotangent squared, that's fine. And then you subtract cotangent squared, and you're left with just 1. A weird one. This thing that looked crazy to start with ended up being just 1. Something like that. Number 4. It's a little bit different type of problem. Find cosine of x given that sine of x equals negative 1/3 and x is between 3 pi over 2 and 2 pi. So find cosine of x given we know about sine and x is between 3 pi over 2 and 2 pi. Well, sine and cosine are related to each other by sine squared plus cosine squared equals 1. And this is me being lazy with my notation here. Sine squared is negative 1/3 squared. Cosine squared equals 1. And I'm trying to find cosine, so I can move things around. Cosine squared equals 1 minus 1/9. Right? If I square 1/3, I get 1/9. It's positive when I square it, I subtract it over. So c squared equals 8/9. I should probably switch this back to, before I forget, that's the cosine of x. So cosine of x is equal to the square root of 8/9. Let's see, I know 8 would reduce, but we'll leave it. 9 I can definitely simplify to just 3. But when we put the square roots on, we got to remember that it's plus or minus. And I don't know which one, but they did give me this information. So let's use this and see what that tells us. So x is between 3 pi over 2 and 2 pi, so that's 4th quadrant, so somewhere in here. So there's sine at negative 1/3. Cosine's right here, so cosine would be positive. So I know that I need to use the positive one, not the negative one, and that's why they gave me this information. If they did not give me that information, I wouldn't know if cosine was positive or negative. So that seemed strange at the beginning, but it helped me pick the plus or minus. All right, last one. Negative cosine squared x minus 3 sine of x minus 3. Well, this looks a little bit strange, except that I can put something in for cosine squared. All right, I know that sine squared plus cosine squared is 1. So if I just move things around a little bit, cosine squared is 1 minus sine squared. So in place of cosine squared, that minus sign still needs to be there, but in place of cosine squared, I'm going to put 1 minus sine squared. Leave everybody else alone for now. Now let's distribute our minus sign. So we get a positive sine squared. You can combine like terms. Negative 1 minus 3 would be minus 4. And the next step is going to challenge some of your algebra because it's factoring. We don't get away from factoring ever. If you still can't factor, we got to learn how to factor. Some of you will be able to factor this as it sits. Others of you may want to do what's called a U-Substitution. It's like, well, there's something squared and then it's not squared, and so it might look easier to factor if I would just replace sine with U. That just looks a lot better. And so if you need to make this substitution, you can, because it just makes it look nicer to factor. Some of you are going to be able to factor from the get-go, and I'll show you how to do that in a minute. So let's see. I think this is an easy one. U minus 4 and U plus 1. If I multiplied, that'd give me negative 4. If I smiley faced, I'd get negative 3. So I'm good on that. I'm not done yet because this wasn't a U problem, this was an X problem. So back in for U goes sine of X. So sine of X minus 4, sine of X plus 1. Now, again, some of you, probably many of you, would skip all the U stuff and would just jump straight to seeing, well, sine times sine would give me sine squared, 4 and 1 would give me negative 4, and if I arrange signs, plus and minuses the right way, I could end up with that minus 3 sine x. So, kind of your call. I do it both ways. If it looks really ugly, I'll switch to U, clean it up a little bit. If it was one like this, I probably would have just jumped straight to the answer because I could have handled that. Oops, we're in Unit 11, Worksheet 2. And again, the worksheet packet is posted. I would only print out what you need in hopes that we will be back at school at some point, and I can give you the packet and you don't have to print out paper. Worksheet 2 is only one page, so that's at least somewhat of a space saver. I've posted answers, a picture of answers, and I've posted me working the odds, or mostly the odds. So give it a try, but if you get stuck, there's resources in Schoology for you to use to see if you can figure it out. All right, hopefully I will see you, or most of you, on Wednesday at school, but we'll see.